Hello, and in this video we're going to go over the composition of functions. That means we're going to take one function, put it into another, and make a composite function out of that. We're going to go over the definition. So this is our checklist for this video. We're going to go over the definition, then we're going to do composition examples with words, tables, graphs, equations. We're going to do those, different composings of functions. And we're going to then look at the domain of a composite function. How do we find the domain? And then we're going to write a composite function into its two different functions. We're going to separate it out. So that's what we're going to do in this video. Okay, let's start with the definition. The definition is when we put the output of one function into the input of the other. And then we say it's a composition of the two functions. It's usually written this way, f parentheses g of x, or it's written with a little circle there, f circle g of x. These are the same. It's read f of g of x, f of g of x. It can be reversed also. You could go g of f of x. All right, so that's the definition. We're going to place the output of one function into the input of the other. So here is our table composition examples. Examples with a table. So here's a table of values, here's our x values, here's our f of x values, here's our g of x values. So if we want to make a composition of f of g of 0, then what we're going to do is we're going to evaluate the output of this function g of 0, we're going to look right here at 0, and then we're going to read over g, that's 2. So that's going to be, this value is going to be 2. So we replace it with that value, and now we're just going to use a chart to find f of 2. So we go down into the thing here, read across to 2, that's going to be -5. So f of g of 0 is -5. If I did g of f of -1, for example. So I'm going to evaluate the output of f of -1. So -1, we go to f, that's going to be -2. So we're going to have this value being -2. And we're going to go down to -2 and evaluate g, which is 7. Okay, so we're evaluating the inside function first, the output of this, and then we're writing the output there, and then evaluating that output into the other function. Okay, sometimes we won't be able to do these. For example, if we had f of g of 2, this one we cannot do, because if we evaluate g of 2, well, I'm sorry, that one we can do. Yes, I picked the wrong one here. We can evaluate that. G of 2 is going to be -1, so we're going to go f of -1. F of -1 is -2. All right, so let me find one that's not possible here. That one's going to be f g of f of -3. Let's try that one. I think that one's not possible. So if we evaluate f of -3, we get g of 4. Well, we don't have a 4 here listed in this chart, so this is not in the chart. And so that means it's not defined. So we can't evaluate that. We've only gone halfway there and we can't evaluate it. So that's how we do composites with tables. All right, and then so we've checked off the definition and we've done tables. We're going to move to graphs next. We're going to do composition with graphs. Okay, so what happens is this is the graph of g of x, this blue line here that curves, and this is the blue line of f of x. So we're going to evaluate some of these. These are written in the other way, so this is the same as g parentheses f of 1, but they put it in terms of the circle 1 here. So what we're going to do is evaluate f of 1. So we read on the chart where 1 is. So 1 is here on the x-axis. We're going to go to the f graph first. That's the bottom one. So this value is -1. So it's going to be g of -1. So then we're going to read to the -1 value on the axis, x-axis. Then we're going to go up to g. We don't go here. That's f. We go to g, which is 3. So this is going to be 3. So the overall answer to A is 3. Okay, I'm going to give you a second. Why don't you try this one? Pause that for a minute, and then we're going to check. Okay, so we're going to do this function first, f of 5. So we're going to go to 5, and we're going to go to f. That's going to be 1. So we're going to go g of 1. And we go 1, we go to g. That's going to be then 4. So you should have gotten 4 as the answer for that one. Okay, inside here, we're going to do that one, g of 0. G of 0, scroll up. G of 0 is 5, even though it doesn't have a point there. So this is f of 5, after we evaluate that and get 5 out of that. And then f of 5 is 1. And f of g of 2, let's try that one. G of 2. G of 2 is 2 again. So then this is f of 2. Because this is 2 already. So f of 2 is -2. So we can also sometimes evaluate the same function, right? If we do, for example, if we do g of 2, that means we're evaluating g twice. So we're going to use this graph twice. So we're going to go to 2, we evaluate 2, that's in this case still 2, so this is going to be 2 again, and then g of 2 again is 2, so that's not very, let's try g of 3. Okay, so we go to 3, we go there, g is 1, so we go g of 1. And so this is 1. Then we go back to the g graph again, and that's 4. So we can use the same graph twice. They write the same function twice. And we can do that on the tables too. If I wanted to, I can do that on a table as well. I could have written on this table f of 1, something like that. And then I go here, 1, go to f, that's -1, so then we're going to evaluate -1, that's what this is. Then we're going to go to -1 and get -2. So we can evaluate, we just use this column twice if it's written with the same function evaluated twice. Okay, so now we've done graphs. Okay, next on the agenda is equations. All right, so there's several different types of equations we're going to do. There's going to be the ones where we actually evaluate the equations. So if we have equations like f of x equals 1 over x plus 2 and g of x equals 4x plus 3, and then we find f of g of -1. Whoops, let's try that. F of g of -1. All right, so we're going to evaluate this inside function first. So we're going to take this g of -1 and we're going to go here and write 4 times -1 plus 3. So that's going to give us -1. All right, again, it's -1 again, because -4 plus 3 is -1, so it's f of -1, which is, put that in here, and you get 1, +1. So if we try a different, let's try a little bit more complicated answer. Let's try 0, f of g of 0. So if we put 0 in here, we're going to get f of 3. And then we put 3 in here, and the denominator would be 5. So this is f of g of 0. So we can plug in values. Okay. The other thing that they're going to ask you to do is write a function. They may put in f of g of x and ask you to evaluate that. Well, that's just taking the function g and plugging into f. So that takes this function here, the 4x plus 3, and it puts it in for this x value right here. So it plugs into the f of x value, so it's going to be 1 over this 4x plus 3 plus 2. So this x value here becomes the function g of x. So that's going to be 1 over 4x plus 5 would be the function. We wouldn't be able to find a value for this because this is not a value, it's a x value. So you should have a new rule for f of g of x. Okay. So let's go reverse on this one, see what the reverse of this is. The reverse of this being g of f of x. Okay, we're going to take f of x, that's this one, and plug it in there. So it's going to be 4 times that f of x. And then we're going to add 3 to it. So the f of x was 1 over x plus 2. We're going to plug that in for the 4 times x plus 3 part. We're going to plug this function in for that, because that's f of x here, inside g of x. All right, and when we just simplify it as much as we can here, so it's going to be 4 over x plus 2 plus 3. If we get a common denominator of x plus 2, that means we're going to need to insert an x plus 2 here over x plus 2, because that's 1. And it's not changing the thing. This is going to be, then we still get 4 over x plus 2 plus 3x plus 6 over x plus 2. So we're going to get 3x plus 10 over x plus 2 as our solution to that. That's g of f of x. All right, so those are the two different ones when we're using equations. So the equation ones can either be plugging in a value, or they can be plugging one function to the other to get a new function. Okay, so you have those two choices on equations. You don't have those choices on tables and that, but that's what you have on equations. So we're equations we've done. Now we're going to do words. Okay, you have an example of a word problem. Okay, this one is the function a of the d value gives the pain level. So a is the pain level from 0 to 10 when you put d milligrams of the drug in their system. So this is how many milligrams is going in there, and then you're finding a pain level. The milligrams that you find after t minutes is this. So this is the milligrams of that after this. So this represents, this is the milligrams of drug after 4 minutes. And A of that is the pain level. So this whole thing represents the pain level after administering drug for 4 minutes. Drug for 4 minutes. Okay, now this one here says this is the pain level when you have 4 milligrams of the drug. So this is pain level with 4 milligrams of the drug. And then it says this is the milligrams of the drug after a time. So this is not a time, so this one doesn't make any sense. This is not a correct composite. Because we can't take a pain level and put it in for time. That's not a time value. This has to be a time value in order for it to be evaluated, because that's what this says. It puts in there a time, but that's not what we got out of the other function. Okay. All right. So this one means here that we're taking the milligrams after t minutes, and we're finding the pain level. So the pain level is 4, so this represents pain level of 4 after t minutes of drug in body. Okay, because this is saying that this is giving the pain level, and that's what it's saying. This is saying it's giving the milligrams, so this represents 4 milligrams after a pain level. So this still doesn't make any sense here. You can't put a pain level in for time, so you cannot evaluate this. Pain level doesn't equal time. What this here is, it's a pain level, and you're supposed to put that in for m of t, and t is supposed to be a time, so you can't put a pain level in for time, so that can't be evaluated. Alright, so 2 of these make sense, the ones with the a and the outside. We can evaluate this being the drug milligrams, put it back into this function. It works because you get milligrams out of this. Okay, so that's the end of the composite part of this. That's the word section. So we're finished with composites. Now we're going to do these 2 last things, which is domain of composite functions and writing a decomposition. So the next thing on the list was decomposing a function into 2 different functions. So basically we're going to take this, we're saying that this is some function f of g of x, and we want to write what are the 2 functions. So if we look at this function, we can see that it could be done in a couple different ways, but the inside function is this one right here for me. It's this one right here. It's inside. So g of x is going to be, for me, this part here. So g of x being inside this is going to be the x plus 2. It's the first thing that we do is that. So if you're thinking about when we plug a number into the function, what is the first thing we do? Well, in this case, I'd write x plus 2. I add 2 to it, so that's I'm going to give that to the first function, because that's what we evaluate. And then the last function is we divide by 4, so that means f, or we divide it into 4. So f of x takes our answer here, and we divide that into 4. So 4 divided by whatever g of x is. So g of x happens to be this. So these are the 2 functions that we have. That's one choice. You could also say that g of x is 1 over x plus 2, and then f of x is just 4x multiplying by 4. After that, we could take this 4 out and just put the whole thing. So there are 2 different correct answers here to this. You could have written it this way or this way. Those are both correct. All right. Okay, so that same thing, philosophy here, we want to look at f of g of x. We're going to look at g of x as the inside function, so that's going to be, to me, what we're doing first. 5 minus x is what we do first when we evaluate that. So g of x is equal to the 5 minus x, because that's what we do. When I say if I put 2 in there, I'm going to go 5 minus 2 first. I'm not going to take the square root first. I'm going to do 5 minus 2. So that will be my g of x function, because that's what we evaluate first in this problem, is the g of x. It's inside the parentheses. Now outside is what the next thing is. So the next thing that we're doing after we subtract is we take the square root. So that's just going to be the square root of x. We take this and we plug it in here. That gives us this function. So these are the two decompositions of that. All right, well, on to the last item in this section is finding the domain. You have to look at the domain of both the inside function and the composite function after simplifying to get the domain of the whole composite. We can't just look at the composite. We've done a couple of these. We're going to write this out, so that means we're going to do g of f of x. We're going to find the composite function as we did before. We're going to take f of x, that's this thing. We're going to put it in here. So it's going to go right, this function is going to go right in there. So square root of 4 minus x squared minus 2. So these two things are going to drop out. We're going to get 4 minus x here minus 2, which is going to be 4 minus 2, which is 2 minus x. So this is going to be our composite function. We have to look at the inside function and the composite function. The inside function being f of x. So the domain of f of x. So the domain of g of f of x is all real numbers except 2. Because you can't put 2 in there, you can't have the denominator equaling 0. So we just say x is not equal to 2 for the domain. All right, and if we wrote that in interval notation, it would be negative infinity to 2 and 2 to infinity if we wrote an interval notation. That's the domain of the composite. But we also have to look at the domain of f of x. So we need to look at the domain of the inside function of f of x. Because it's really that we have to evaluate, when we stick it in there, we got to make this work first before we square it. So we also can't have values that don't work in the square root. So in the domain of f of x, it's a square root. So that just means that that has to be greater than or equal to 0. So that means 4 minus x has to be greater than or equal to 0, or we can't take the square root of it. If we then move the x over, we get 4 is greater than or equal to x. That means x is less than or equal to 4. Okay, so that means that this has to happen as well as that happening. Okay, so that means that we can only go up to 4 on this. So that means it's going to restrict this domain, then changes to negative infinity to 2 and 2 to 4. Because we can go up to 4, it has to be less than 4. So this infinity changes to 4 because we have a border at 4 now. We can't put anything more than 4. If we try to put 10 in here, 10 works here, but it doesn't work in this function, and this is really the original function right here before we simplified. So if we put 10 in here, we'd get a negative 6. We can't take the square root of negative 6, so it's not possible. So we have to stop at 4. As we go in, because that's what the domain of the inside function tells me. It's a composition of the inside function and the whole function. So this is my answer to that problem. Okay, now we've finished with this checklist of things that we've done here. We've done domain, and we've written a composition.